GeoSketch is implemented as a plugin to Google SketchUp. Here we have the toolbar that are the standard SketchUp 8.0 tools, and across the top we have the toolbar for GeoSketch. For the first demonstration, we'll import video frames that were taken from a small aircraft flying around Providence, Rhode Island. We have the option to either individually load in frames or to load in a series of frames. In this case, I'll load in every 10th frame from the video. And the frames are imported and placed at the location that the camera was at the time the frame was taken. So if we look at it from above, we can see the flight path of the aircraft around the city. We can rotate around and look at the individual frames. When we're inside of one of the GeoSketch construction tools, then we also have the ability to use the arrow keys to flip between the images until we get to the image that we want. In this case, I'll use the rectangle tool, and I'm going to build the rectangular footprint of this building. There's a coordinate system associated with these oblique images, and in this case the street level is at -22 feet in that coordinate system, so I'll choose that as my working plane, and then I just select 3 points to define the rectangular footprint of that building. I can't see the other corner, so I'll use the arrow keys to rotate around where I can see that other corner. When I click the third point, GeoSketch will construct a preliminary primitive already textured, and now when I use the standard push-pull tool, each time I move a face it'll retexture from those oblique images, and I can use this on the sides as well and refine the geometry to match what I see in the oblique images. And we can also do that on the bottom as well until we see the pixels line up on the bottom edge of the building. So that's a simple rectangular building. One problem that we see is that one face is obscured by another building. So select that face and use the tool that will allow us to choose a different face to texture it from. Here's the oblique image that was used by default because it's closest to looking square in on that building. And I'll rotate around to an image where it's not obscured. There's a high skew angle, so there's a little bit of error in the camera model, but we can go in and manually grab these corners and put them where they need to be in the image. And do that at the top, and then go down to the bottom and move those. And retexture that face. And if we know the building is symmetrical, there's a tool that will copy that texture from that side over to the other side. Now I'll build a more complex case using the GeoSketch line tool. And we'll zoom out, and again we'll rotate around to where we can see the footprint of the building. But in this case it's a more complex profile. It would be easier to define it up at the top of the building than down at the street level. So we're currently still working at our altitude of -22 feet. I'll put my cursor at the street level of that building, then hold down the Alt key to measure the height of the building. It's about 189 feet tall, and we'll set that as our new working altitude. So now we can define our profile up at the top of the building. And here's where we'll see the specific inference engine that is part of GeoSketch. As we construct this geometry by digitizing points in the image, the inferencing is telling us when the projected geometry is perpendicular to the existing edges. As we go across this part of the building, it's not perpendicular, but now when we get over to this corner, we do get perpendicular inferencing. And we can go back to this corner here, and we'll switch to the arc tool and go over to where we started, and then it will also tell us when our arc is tangent to the adjacent edges. And since we started up at the top of the building, we'll use the push-pull tool to extrude it down to the same level as the other building. Now in this case we were just working with these oblique images that were taken from the video frames. We'll look at another example where we have both the video frames and we also have a nadir image. So in this case we also have a shapefile, and GeoSketch has the ability to import from a shapefile. We'll select that tool and navigate to the directory where the shapefiles are. And we have the ability to import either aerial or linear features from shapefiles. In this case it's aerial features. And it reads the attributes that are in the shapefile and if there is a height attribute, it'll find that, if we can select it from a drop-down list, and we need to just specify the units for the height attribute. In this case they're in feet. We have the ability to filter by attribute values and to pull in FID and SMC values from the attributes. And then it'll read in the footprints from the shapefile and construct the geometry from the height information. The top face is textured from the nadir image, and the side faces are again textured from our oblique camera images. And we have that same problem of the obscured building, but we can use that same technique to fix it. So now we'll look at a third example where we're going to read in a simple nadir image. In this case it's a nadir image from Google Earth. And so we use the pitched roof tool, and we'll specify that we're going to define our geometry from the ridge of the hip roof. And then we just digitize points in this nadir image. Do them here on this roof line. And we use the image again to determine where the eave is. And then we'll change our parameters such that we're building the main part of the house, which is a two-story building. And we'll again digitize the ridge line of that hip roof. And our inferencing will tell us when it's perpendicular to the previous section that we made. And then we'll switch to doing ridge-ridge for our geometry. So we'll intersect the existing roof plane, and our inferencing will tell us when it's perpendicular to the existing roof line. And we can do that over here as well, this small section. Here we get our inferencing, and we'll build this section that's from that edge. It's perpendicular to that roof line, and we'll line up the eave from the image. Important mousing break due. So next we'll switch to the gable roof style, because this part of the roof has a flat end. Do the same technique of identifying the ridge line, getting the inferencing that tells us when it's perpendicular, lining up the eave in the image. Then we'll switch back to the hip, and over here we have a very small section of a hip roof. So we'll digitize from there, and construct that part of the roof, and then finally this section here. In this case our inferencing tells us when the eaves match. So all that, as we built that, we were building our geometry in 3D, and these are all built as separate groups so that we can use the SketchUp tools to perform Boolean operations. In this case we'll use the outer shell tool. Select the main part, this section, this section, this section. Each section is built as a separate group, and the outer shell tool intersects all that geometry and creates it as one contiguous piece of geometry. And we'll turn on the perspective, and when we look at this we can compare it to an oblique image. You can see that just working from a nadir image we were able to construct a good representation of the 3D structure of that roof. So that concludes the demonstration.